One of the many reasons for running a hypervisor cluster is to reduce downtime. In other words, if you've got a standalone hypervisor and it fails, then all of the virtual machines that it was running will go out of service. Now, fortunately, hypervisors like Proxmox VE can help to reduce that downtime because they provide a high availability service. So provided that the hypervisors have all got access to the same shared storage and you're running virtual machines from there, then if, for instance, one of your nodes were to fail, another node can then actually start up those virtual machines. But how do you configure high availability in Proxmox VE? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, because this video is specifically about setting up high availability, I'm going to have to make some assumptions, otherwise the video is just going to get too long. So the first thing is, I'm going to assume that you either already have a cluster or you know how to actually create one. Now in my case, my cluster is made up of 3 servers, which is really the minimum that you should have. But you can have larger cluster sizes. It's just best that you've got an odd number of servers in that cluster. In any case, if you don't know how to create a cluster, I do have another video that you can check out which shows you how to actually create one. Now, another assumption is that your hypervisors have all got access to the same shared storage because that's essential for high availability. In other words, if you're running a virtual machine on a hypervisor, but its files are stored on the local hard drive of that server, well, if that server stops working, none of the other hypervisors can get access to the files, so they can't start the virtual machine. Now, there are different types of shared storage available. In my case, for example, I'm using an NFS share, but what you use is entirely up to you, as long as all of your servers have got access to the files of your virtual machines. Now, if you're not familiar with how to set up shared storage on Proxmox VE, I do have a video that shows you how to set it up to connect to an NFS share. Now, my last assumption is that all of the actual servers in your cluster are keeping the correct time. And that's because for HA to work properly, the clocks on these servers do need to be kept in sync. Now, by default, a server should be trying to connect to the internet to get its time from an NTP server. So unless you're actually blocking that access, you should be fine. However, it is still worth double checking. The easiest way to do that is to navigate to Data Center and then to HA. And then you should be able to see what the actual times are on your actual servers. And then you'll be able to check if they're all in sync or not. Now, the first thing to do when it comes to setting up high availability within Proxmox VE is to create a high availability group. Because what this determines is which of the nodes within the cluster a virtual machine should be running on. So to do that, we go to Data Center, then down to HA, and then click on Groups. We'll then click on Create to create a new group. You then need to give it an ID, so make this something meaningful, something that makes it easier for you to understand what the actual group is meant to provide you with. So, for example, I'm going to call this one All Nodes, because I want to set up just basic redundancy. I want to be able to set this up so that my virtual machine can run on any of the nodes within the cluster, for example. I can pick out individual nodes from the cluster, or what I can do is just select them all in one go. So that's useful if you've got a large number of servers within your cluster. You can be very selective if you want as to which nodes your virtual machines can actually run on. But I'm just going to keep things simple for now and just leave it at that. The other settings I'll cover later. To create the group, we then just click Create. And we've now got a group that we can use to assign virtual machines to. Well, now that we've got a group created, we can start setting up high availability for our virtual machines. And this is done on a per virtual machine basis. And there are actually 2 different ways that we can do this within Proxmox VE. One option is to pick a virtual machine and then click on the More drop-down menu and select Manage HA. Another option is to go to Data Center, go to HA, and then under here where it says Resources, you can click Add. Then you can pick out a virtual machine from the list. And as you can see, we get exactly the same dialog box, no matter which of these 2 options we choose. Now there are a few different settings that we've got for high availability for this virtual machine. I mean, obviously we've got the virtual machine itself picked out, but we need to set what group it's going to belong to. So click on the drop down menu, and I've only got one group to choose from, so I'll select that. Over here we've got max restart. Now this is the maximum number of attempts to actually restart a virtual machine on a node if that actual virtual machine has stopped, for example. So let's say we've got a virtual machine and it's running on one of the nodes and it just stops working. So it goes into a stopped state. This is going to determine the number of attempts that the resource manager will use to actually try to get that virtual machine back up and running on that same node. So you can set this to whatever you particularly want. By default it's set to 1. Let's say, for example, we'll change this to give it 3, just to give it a bit more of a fair chance, for instance. We've then got max relocate. I'll set that to 3, for instance, but what that determines is the number of attempts that will be used to actually migrate the virtual machine to another hypervisor in order to get it back up and running. Now, when I say to get a virtual machine back up and running, it really depends on what the actual request state is. By default, it is actually set to started. If you click on the drop-down menu, there are other states that you can actually target. Most cases, you would want the actual virtual machine to be running. If you want to know what these are, you can click on the Help button here. It opens up this tab and it gives you a bit more actual details about what these actual other states are. So that may be for, say, maybe you're decommissioning things, or maybe you're in the middle of maintenance, for example. But typically, you'd want the virtual machine to be in a started state. In other words, you want it to be running all the time. The other field that we've got here is the comment. Now, this is useful to give the actual virtual machine a more meaningful name within this window pane here. So let's say, for example, this is my DNS server, for instance. When I click on the Add button, you'll see we've now got a more meaningful description as to what on earth it is we're doing here. So we've got VM 101, for instance. We know it's called Zorin 1, but this is a bit more meaningful, saying that this is DNS server number 1. As you can see, it's already kicked off and it's in the process of actually starting up that virtual machine on node number 1. And that's basically because we've actually got a group set up where we weren't very specific in terms of which node we actually want that virtual machine to run on. But you can actually reassign these. You can set these up with different groups, and then you can start to be selective, for instance, in terms of which node you actually want a virtual machine to run on. Now, I've since added in 2 virtual machines for the resource manager here to look after. So they all belong to this group, all nodes, which means they can run on any of these 3 actual nodes. They were all originally assigned to node 1, so when they've started, they've all been left on node number 1. In other words, there wasn't a particular reason to actually migrate any of them to node 2 or node 3, but you can influence which node a virtual machine runs on by creating groups and setting different priorities for the nodes within that group. So let's say, for example, we want Zorin 1 here to run on node 3 during normal operations, in which case we're going to go to groups here, click on create, and we'll create a new group. So we'll call this one, say, prefer node 3. We'll select all of our actual nodes and we'll give node number 3 the highest priority of 3, for instance. What we do with the other 2 nodes really depends. I mean, maybe we'll set it up like this, for instance. So under normal circumstances, the virtual machines will run on node 3. If not, we want them to be running on node 2. If not, we want them to be running on node number 1. In other words, 3's got a higher priority than 2, which has got a higher priority than 1. On the other hand, maybe we're not too bothered about which of these other 2 nodes get used, in which case we could leave the actual priority to be the same. So we're just going to click on create to create a new group. If we go back to HA, we'll pick out this Zorin 1 VM, click on edit, and now we're going to change the actual group to be prefer node 3. Now, one thing to bear in mind, as soon as I click on OK, we're probably going to end up with a possible disruptive change here. That's because we're then going to be instructing the actual resource manager by changing the group to tell it that, well, actually, we prefer this virtual machine to be running on node 3. that means it's then going to, as soon as possible, and as soon as it realizes, it's going to then migrate this virtual machine over to node 3. And that can actually be disruptive, so you do have to be careful when you're changing the group. So I'm going to click on OK. And we just need to leave it a short amount of time, and then at some point the state should change to say that it's going to get migrated. And then what we'll see, there you go, state's now changed to migrate. And then shortly afterwards, you'll see this will start to change. It'll actually tell us that the virtual machine's being locked down there. The config's now locked, and we've got a little arrow showing that it's in the process of being migrated. And then shortly after that, you'll start to see it pop up on node number 3. In other words, because we've changed the group and we've set a preference within that group for node number 3, as you can see, it's now in the process of migrating that virtual machine across to node number 3. Now, this is a very good HA system like other hypervisors, where you migrate a virtual machine from one node to another, and usually it's not that disruptive, but it can be all the same. So just bear that in mind when you change the group and it has an influence on moving the actual machine. It can cause problems, so it's probably best to do something like that out of hours. Well, now that we've got high availability set up for our virtual machines, it's time to actually test this. So we've got Zorin 1 here running on node number 3. So if we go over to its console here, we'll see what state it's in. I need to log back in. So it's pulling away, pinging the actual default gateway. Now, bear in mind, this is a virtual machine within a virtual machine. In other words, these Proxmox hypervisors that I've got are actually nested virtual machines within ESXi. So it's not that fast, I must admit, but it does actually work pretty well. It's actually quite quick to detect failover solutions, especially compared to like a manual issue where a server falls over in the middle of the night, for example, and you don't find out till the next day. So what I'm going to do is to actually simulate this actual server 3, node 3 here, actually losing power, for instance. And I can do that through ESXi just by simulating a shutdown. So I'm going to click the power off button for node 3. And then what we'll see at some point is, there you go. So we've basically lost access to the console here. At some point, node 3 is going to disappear, as you can see here. If you go back to data center and HA, after a short while, what should happen is that it's no longer being detected by the cluster, and it'll actually, there you go, it's now saying, oh, this is an old timestamp. Is the actual server dead, basically? Now, it is going to take a few minutes, I've noticed. It can take about 2 or 3 minutes, but again, bear in mind, this is like a completely virtualized environment that I'm running here. But when it does actually detect that this server is no longer available, in other words, the node's down, it'll then kick in with high availability, and this virtual machine should get actually migrated to one of these 2 other nodes, depending on what our preferences are within our actual group. Now, we've got it set up for node 3 as the preferred node. So if we go into that group, we've got equal priority. So it could end up on either of these 2 nodes. We've just got to give it time to actually detect the actual outage and then start taking action. Well, as you can see, Zorin 1 has now been assigned to node 2. The group that we've got could have put it on either node 1 or node 2, but what the resource manager chose was to put it on node 2. Now, if I click on that, go back to the console and see what state this is in. So I've actually got a login prompt, so it's back up and running. And I stress that because it underwent a cold start. In other words, the virtual machine was running on node 3, but what isn't happening is the actual state of that virtual machine. In other words, all of its memory actually ending up within files on the shared storage. That virtual machine was running on node 3 within the memory of node 3. So when node 3 went down, whatever it was up to at the time has been lost. So although HA kicked in, it had to do actually a cold start of this virtual machine and start it up from scratch. So whatever it was in the middle of doing, as I say, has been lost. Now, that's not really a big thing. In this particular case, it was just pulling the default gateway. But typically, you'd be running servers that have got services that are running anyway. They would automatically start. So you'd lose them for a short amount of time and then they'd kick back in again. So maybe you'd lose a web server or something. So you'd have one less web server available for your web farm and so on. But it doesn't take that long to actually recover. It's just really down to how quickly it takes to detect the actual outage and then how long it takes to bring that virtual machine up. In this case, it took quite a few minutes because this is all in a virtualized environment anyway. It would be a lot quicker if this was a bare metal solution and all these were physical actual hypervisors. Even the actual NAS that it's using is really a virtualized true NAS server. So even still, it was pretty quick, especially when you compare it to like a manual outage. Now, granted, within a business, you'll have teams that are working outside of hours, for example. They'll get notified and they could take manual action to get an actual virtual machine back up and running. But this, all the same, this leaves you with very, very little downtime, just a few minutes, because it's pretty quick to detect an outage and it's pretty quick to get a virtual machine back up and running. It really just depends on what that virtual machine is actually doing as to whether it's good enough. Like I say, I mean, if it's a service, it'll automatically start back up. If it's an application running in the actual foreground, running within the actual console session, then it would be lost. But yeah, it's still very, very useful. Now, to compare that with, say, other systems that have got dedicated HA solutions, typically where you've got a pair of computers that are constantly monitoring each other, that's a different story. Those will work at an application layer level where they'll be able to detect if the actual application on the computer has actually stopped working. They're much more sophisticated in terms of what they do, whereas this is just basically checking to see, has the actual virtual machine stopped working, and then it'll try and get it back up and running again. But all the same, it's still a very useful feature to have within a virtualized environment. Now, if you're going to be using priorities within high availability groups, then there is one setting you need to pay close attention to, particularly if you want stability. And that is this setting here, no failback, because by default, it's not enabled. Now, the situation that we've got at the moment is that we've got a group here of 3 servers. Node number 3 is the preferred server. It's got the highest priority. The only thing is, node number 3 is currently offline. So my virtual machine here, Zorin1, which belongs to that group, is currently running on node 2. Now, once node number 3 comes back online and is available for use, what it means is that the resource manager will then try to migrate this virtual machine back to node number 3. In other words, it's going to carry out a failback. Now, the concern with that behavior is that if you've got a lot of virtual machines, that's a lot of virtual machines to be migrating back to that actual node. And if that node comes back up during normal working hours, that could be an issue, although it doesn't necessarily cause disruption, or at least that much when migrations take place. It's still technically a change carried out within normal working hours, which maybe a business you're working for doesn't allow, for instance. The bigger concern I would have, though, is that if this server had intermittent problems, so let's say it encounters maybe a hardware or software problem and it results in the server restarting. The system's got just enough time to start to move some of the virtual machines off onto other nodes, by which time the server's back up and running again, in which case it then has to start moving those virtual machines back again, only for the server to then go offline. So that's not really a stable situation to be in. There is no maintenance mode per se, at least not now that I'm aware of at the time of recording, for Proxmox. So this default behavior means that as soon as the server's back up and running, you're going to have a server where it will actually try to put these virtual machines back on the server. It's not going to come up in some sort of maintenance mode, for instance, like you would get on ESXi, for instance, which would prevent that from happening. So that is something you need to be aware of. So personally, what I would prefer to do is tick that box and say no failback. But just to demonstrate that, what I'm going to do is I'm going to start that server back up again. And what we should find is the virtual machine, sure enough, does get migrated back. Well, just like I was saying, once node 3 came back online and became available, the virtual machine that was originally on node number 2 has been migrated over to node number 3. Personally, I don't see that as a particularly stable strategy to have. So I think the better option is go to Edit, and we'll select No Failback for this group. So what I'm going to do is I'm going to shut this actual node back down again. And then eventually it'll detect that the actual server is no longer available. It'll move that virtual machine off to one of the 2 nodes here. And then what I'll do is I'll repeat the process again. And what should happen that time is the virtual machine should stay on that specific node. So this time, the virtual machine has been moved back to node number 2. I've actually started node number 3 back up again. So what we should find this time is that once the actual server becomes available, because we've actually got no failback actually selected as an option, although this is the preferred server in the group, what the system won't do is actually try to move this virtual machine back to node number 3. Well, as you can see, node 3 is now back up and running, and I deliberately left it plenty of time just to make sure that the resource manager didn't try to migrate this virtual machine back to node number 3, but sure enough it hasn't. Now if I go back and edit that group again, if I deselect that option, in which case we're back to the default behavior, click on OK. If I leave it long enough, then what should happen is, there you go, it's automatically now trying to fail that virtual machine back to node number 3. So it is something you can always change your mind on if you particularly want to. Now one more setting that you can use within high availability groups is this one here, restricted. Now this group that we've got here is made up of 3 servers. If I were to deselect nodes 1 and 2, what this actually means is that by default, even though nodes 1 and 2 aren't actually part of the group, if node 3 were to go offline, the resource manager can use other nodes within the cluster that aren't part of the group. So we'll test that out. I'm going to click on OK. So technically this is the only actual node that the actual virtual machine we've got here can use. But if I power this server off, what should happen is that the resource manager will detect that server is no longer available. And then what it should then do is to migrate the virtual machine over to one of these 2 servers. Most likely it'll go over to node number 2 because at the moment it doesn't have any virtual machines running on it. But we'll leave that for a while and we'll see what happens. Well, as you can see, our virtual machine is running on node number 2, and that's just because we didn't place any restrictions on what nodes are available to the resource manager. So ideally, we want this to be running on node number 3, but node number 3 is no longer available, and there are no other nodes available within the actual group to use, so it's just gone with whatever other nodes that were available within the cluster. But if you do want to be selective in terms of which nodes a virtual machine should be running on, particularly if, for instance, you actually want to keep virtual machines apart, you don't want to end up in a situation where 2 virtual machines are running on the same node, then that restricted option does make a lot of sense. Now the one last thing to point out about this restricted option is that this only affects the resource manager for high availability. In other words, it's not going to stop me from manually migrating an actual virtual machine to another node. So if I edit this group and I put on restricted, you can see as far as the group's concerned, only node 3 is part of the group. So if I click OK, what that means is that if node 3 were to go offline, well, this virtual machine is going to stay offline as well until node 3 comes back up and running. But if I manually actually select that virtual machine and tell the actual cluster to migrate that over to node number 2, for example, it's still going to migrate this virtual machine. Even though we've got a restriction option placed on the actual group itself, and the only member of that group is node number 3, it's still going to migrate this virtual machine over to node number 2 anyway. Now, one setting that you might want to think about changing for high availability is the shutdown policy. If you go to Data Center and then select Options, then click on HA Settings and click Edit. Our shutdown policy here by default is set to conditional. Now, there is a drop-down menu where you can choose other options, and if you click that Help button, you'll get a tab here which gives you more details about what those actually refer to. But what this default policy means is that if I go to a node and click on the shutdown button, then it'll go through a graceful shutdown. So what that means is it'll shut down the virtual machines, it'll shut down the containers, and then it'll shut down the actual node itself. Now, at some point, high availability will kick in, realize that any virtual machines that were running on this actual node that are now actually shut down should actually be up and running, in which case it'll actually start them back up again on another node within the group or the cluster. The only trouble with that is you're not really maximizing the actual uptime for that actual virtual machine, and that's what we're really using high availability for. We want to minimize the actual downtime, but we'll have shut the actual virtual machine down, waited a while, and then started it up from cold. So what you can actually do is change that setting if you want to. So go back to the shutdown policy here. If I change that to migrate, click on OK. Now what's going to happen is if I click the shutdown button, it's actually going to shut down virtual machines and containers which aren't protected by high availability still. But for those actual virtual machines that we've got high availability set up for, they'll actually get migrated to other nodes first. So it does maximize the actual uptime for these virtual machines that we want to keep up and running for as long as possible. So there you go, you can see it's locking the actual virtual machine so that it can migrate it across to another node. One thing to point out though is that it doesn't affect the actual reboot button. So if, for example, we were to do patching on an actual node and then we need to reboot it, well, when you click on the reboot button, it still goes through that same shutdown process. All of the virtual machines will be shut down, and then you've got to wait for the actual high availability resource manager to detect they're actually down, and then it'll start them up from cold on another node. So really that shutdown button is more for probably maintenance, planned maintenance. Maybe you're going to replace a part of the hardware, for example, or maybe it's a case that there's some work getting done in the area and you have to actually shut these actual servers down. For whatever reason, that's all that policy affects. And it doesn't affect non-HA virtual machines, just the actual virtual machines that you've got covered by high availability. But it is still a useful feature. Now, version 7.3 of Proxmox VE introduced a new feature that you might want to consider for high availability. So if you go to Data Center, then click on Options, and then here we've got Cluster Resource Scheduling. So select that, click on Edit. By default, it's set to Basic, but there is another option, which is Static Load. So if you click on the Help button, it brings up this tab, and it gives you a bit more information about this other alternative we've now got, which is the actual static mode. This mode, what it does, basically it offers a more sophisticated way of finding out the actual load on other nodes to decide where to actually migrate virtual machines to. So the basic mode is just basically doing a count, whereas the static version is actually checking things like the amount of CPU, the amount of memory usage, to see if it's possible to actually spin up a virtual machine on another node. So it is a more sophisticated way, and probably a better way really, but as they say, it's in technology preview, so you might want to consider it in maybe a test lab, for instance, but in a production lab, probably want to be a bit careful. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, as that'll help get the video out to more people who might find it useful as well. If you've got any comments or suggestions, please post those in the comments section below. And if you're new to the channel and you'd like to see more content like this, then yes, do subscribe. Just remember to set the bell icon to actually send you notifications when new content gets released, although I also post to Twitter as well as Facebook. If you'd like to help the channel and support it, you can actually make contributions through PayPal and Buy Me a Coffee. I've also got links to Patreon, and there's also the join membership option for YouTube itself. Patreon and YouTube members do have the option to actually benefit from early access as well. But above all, many thanks for watching this video. I'll see you in the next one.